Okay, we're still on the ambiguous case, but now let's do a couple of problems on there so that we could see what is actually happening. So I pre-drew these because I am going to tell you that this is the ambiguous case with two triangles. So let's figure out how to do that. This is going to be the one that requires the most work, and so I think we should start the video with that. So I know that we're given angle beta, which is going to be 43. So I'm going to say that this angle right here is going to be 43. And then the side opposite. So I know that this one here is going to be the ambiguous case because I have an angle and then I have the side opposite on there and it's a side angle. So I know that this one here is going to be 43, which is your beta there. And then opposite of my triangle. And so this side, the blue side is the actual opposite side, is going to be the length of 15. So this one here is going to be 15 meters and this one here is going to be 15 meters because it's exactly the same size. And then this one here is going to be 17. Now, besides knowing, and I already knew that this was going to be the ambiguous case two triangles, we still have to figure that out. So the only way that we're going to figure out and see if that's the case is we actually have to figure out what the height is. And so we're going to have to drop the height down of this triangle, and I need to know what h is. So the way that you know what h is by doing this triangle right now, which is going to be straight a right triangle. This is your h, this is 17, and I know this angle is 43. So if I want to know what h is, and it's a right triangle, SOHCAHTOA comes into play. So it's going to be opposite over hypotenuse. So that's opposite over hypotenuse. This h and that h is not the same, so I'm going to just capitalize it. There you go. So that h is not the same. So in order for me to solve for it, it's going to be the sine of 43 degrees is going to be opposite h over hypotenuse, which is 17. And so here, if I looked at that, I could put this over 1 and then solve it. So I end up with the h is equal to 17 sine of 43 degrees. So once you solve for that, you end up getting h is equal to 11.59. So I know that h is 11.59, and so this here is going to be 11.59, and so the 15 falls in between 17 and 11. So I know it's going to touch here, and it's going to touch on the other side of h. So anything between 17 and 11 and a half, any of those values would give me two triangles. So that's, you first have to do this before you know it. So then the next thing you want to do is, and I'm just going to write this down, that h has to be, that your b, the side B here has to be between your H, and it has to be smaller. The biggest one has to be 17, and then your H is 11.59 has to be, and then B has to be in between those values. And so that's where it is. It is 15 on there. And so it checks. Okay, so now that I know that, I'm going to start filling this in because I know how to solve for it. Now, here's the thing is that it's two triangles, so you're going to have to fill in a couple of things on there. So right now, the basic A and B, I know that this here is going to be 15. That C is going to be 17. And that A, we don't know. And then we know that beta is going to be 43. And we also know, and then that's it. That's all we know. But there are two triangles. So this triangle is this triangle right here. That's this triangle there. And the whole entire triangle right there, that's this whole entire triangle. And so we know some information from those triangles. Look at what doesn't change. The 43 is still going to be this angle, and this is still your 43. That's this angle. That's this angle right here is this angle right there, and that's this angle right there. So they're the same. The 17 also does not change. That is still going to be 17. This is still going to be 17. That's this side right there that's being shared by both triangles. And then the blue one, that's your 15. So this here is going to be your 15. and this one here is also your 15. So they're both going to be 15. That's both of these blues. And so now that's all they share. That's all they share on there. And so this angle right here is different than this angle right there. And so this angle right here is different than that angle right there. And the sides are also different lengths, if you could see it. So I am going to write this on here. So the one that we're going to do is the standard one. So this one here is going to be your standard triangle. So if this here is beta, and this is your B, and then this one here is your C, then this one here is going to be gamma, this is alpha, and then this one here is going to be A. And then these are still the same thing, but now we're going to call this A prime, and then this is going to be alpha prime, and then this one here is going to be gamma prime. So we need to figure what those are. So there's going to be another A that we need to solve for. There is going to be, this one's going to stay the same, that one's going to stay the same. There's going to be another gamma, and there's going to be another alpha. So there's two of those. Okay. So how are we going to solve this? This looks like it's really complicated, and it's really not that complicated. So I'm going to try to erase a couple of things here so that we could see what's going on. I'm going to get rid of this H and this 15 so that I know what's going on here. So here's a couple of things that we need to know. So I know that this triangle, just a triangle in the inside. So I know that this triangle right here is an isosceles triangle. So I know that this, oh man. So I know that this side and this side are congruent. So if they're congruent, that means that the angles opposite are also congruent. So if those are congruent, I know that if I solve this beta, so that's the gamma there, I'm sorry, I say beta, but that's the gamma there and this gamma, they're the same, then this is also going to be gamma. And then I could solve this, which is gamma prime, because these two have to add up to 180. So let's do that. The first thing we need to do is find what gamma is. So in this triangle, I need to find what that gamma is. It's still the law of sines. So I'm still going to use the same thing that I did before with the law of sines. So we are going to take the sine of 43 over 15 has to equal to the sine of gamma over 17. And then we're going to do the cross multiplication on there, and we are going to solve it. It turns out after we solve it, we're going to get, let me just write that out for you. So it's going to be, when you solve it, because this is the only thing that we don't know is that gamma there. So we're going to do 17 sine of 43 has to equal to 15 sine of gamma. And then when you solve this, we want to get this by itself. So this is going to be 17 sine of 43 over 15 equals to sine of gamma. In order to get the angle by itself, if you remember, we have to do the inverse. So what we do is we multiply this by the sine inverse, and the sine, it's not really multiplication, it's just the format on there. And so this cancels out, and we are left with gamma is equal to 50.62 degrees. Dot, dot, dot. Don't forget to save it in there. And like we talked about. So that means that this gamma is 50.62. That means that that gamma is also, because these are the same, because it's an isosceles triangle, and this is gamma prime. That this angle right here is this angle right there. But in the triangle, these two are the same. So if this is 50.62, I could figure out what this obtuse angle is just by subtracting from 180. So we write down that gamma prime is equal to 180 degrees minus 50.62 degrees. So gamma prime is going to be 129.38, an obtuse angle. So now we have some answers. So here we have that gamma is going to be 50, 50, 50.62 degrees, and this is going to be 129.38 degrees. Okay, so, and then we continue solving. So now we want to find out, let's see. So now we know what the gammas are. We could also find the other ones now because we could just subtract them from 180, right? So I could add these up. So here I could add these two up and find out the other one by subtracting them from 180 because they have to add up from 180 because they're coming from the same triangle. So if I know these two, then alpha is going to be 86.38, and therefore alpha prime is going to be, so the answer to this is going to be 7.617 degrees on there. And so those are the angles. Now we just are left with alpha and alpha prime. All right, so now how do we find alpha prime? So here we should have stored the angle of A in there, and so then we would be able to find a sine of 43 degrees, and we're storing this alpha in there, and so it would be the sine of 43 over 15. That's equal to the sine of, and this is going to be the regular alpha from this triangle, all over A, which is what we want to solve from there. So hopefully you stored this into your calculator, and then we do the cross multiplication. And then we solve. A is equal to 15 sine of alpha, which should be stored into your calculator again, and then sine of 43. And so then you calculate that in there, and then you get your A to be 21.95 centimeters. Is this what we're talking about? No, meters. So this is meters, this is meters. And so this one here is going to be 21.95 meters. And then we have to do the same thing with the other side. So you have to do, again, the sine of 43 over 15 has to equal to the sine of alpha prime over A prime. And you have to do it again. And so we get A prime sine of 43 equals to 15 sine of gamma prime, and then A prime is going to be sine of alpha prime, which should be stored in your calculator, and then it would be sine of 43 degrees. And then you put that in your calculator, and then you solve for it, and it turns out that A prime is going to be 2.92 meters. And so that is your answer here. It's going to be 2.92 meters. Okay, so that's how you solve this triangle. It takes a while on there to solve the two triangles, and you might need to watch this a couple of times to make sure you're following through on this. Okay, and then here, what we want to do is we're going to solve for this, but here's the issue, right? One of the angles is 105. That means that it's not an acute triangle. It's actually an obtuse triangle. So we're going to make this an obtuse triangle. And so now we have an obtuse triangle there. And so we have this to be 105 right there. And then the this one here is alpha. So this one here has to be 7 inches. And this side right here is your B. So that's going to be your adjacent side, which is 10 inches. So this is B, this is A. Now here's the problem. If this is 10 inches, that means that this one here is only going to be this long and therefore not going to be able to reach it because it's going to be less than that measurement. So that means it's going to be there. And so if this here is A, then it's not going to form a triangle. So therefore, no triangle, no solution. Done with that problem there. Okay, what about this one here? This one here says that it's an acute triangle. So this one here is going to be 25. That is your alpha. The side opposite. So therefore, this is going to be A is 4 millimeters. And then there is your B, which is 12 millimeters there. And so then we have to figure out, that's your B. If I'm looking at this, I have to figure out what the height is because I need to know the height to figure out whether I'm going to have this to be 4 millimeters is smaller than the height. So then we are going to drop the height, make a right angle. That's your H. So you're going to have a triangle now. That's H. And you're going to have this to be 12 and this to be 25 in the angle. So it's going to be the sine of 25 degrees is going to be opposite over hypotenuse. So H is 12 sine of 25 degrees. Then when you put that in there, it's going to be H and you calculate it. You're going to get, let me see. You're going to get H to be 5.07. That means that H is greater than A. And so therefore, that means that this is 5.07 is greater than 4. So therefore, it's no triangle. So there is no solution, no triangle. And done. Okay. So I guess that does those cases. If it was one triangle, you would just solve it like we solved up here, but with only one triangle, and like we solved the ones in the other cases. And so that is the ambiguous case. It is the pain.